Hello everyone and welcome back to our channel Quaint. Today we are going to explore one of the most fascinating hidden processes in computer science. How your C++ code magically transforms into machine instructions that your CPU can understand. You know, CPU can understand only opcodes and operands, or better to say your CPU can understand only ones and zeros, binary digits. Okay, but you know your C++ language, that is not in terms of binary digits. Show how your CPU actually understands this. That means one thing is required, and that is what? That is translator. A translator is required which can transform your C++ code in terms of ones and zeros, means machine instructions. Name of that translator is compiler. In the field of computer science, this is called compiler. Okay, so you have written your code in C++. That means it is a high-level language. Means this language is closer to human logic. That's why this is called high-level language. And your machine instructions, those are actually low-level language. Anyway, you have written your code in C++. So now, function of the compiler is to convert this your C++ code into what? Into those machine instructions. And for that purpose, you know, in C++, different keywords are used, like if, while, cout, cin. But these things actually your CPU cannot understand directly. Indirectly understands, that is known to you, but cannot understand directly. Cout, cin, then int for integer, long for long variables. So many keywords are there. If you are habituated in writing C++ code, then it is known to you. Anyway, your CPU cannot understand all these things. So your entire program needs to be translated or converted into machine instructions. Then only your CPU can understand all these things, and accordingly they execute the program. They means here I am talking about CPUs. Anyway, so different steps are there which are followed by your compiler. First step is lexical analysis. This actually breaks your entire code into tokens, just like words in a sentence. Next is syntax analysis. First one was lexical analysis. Second one is syntax analysis. That means it checks whether your program or your code has been written following the C++ grammar rules. Okay, that is checked in this step known as syntax analysis. Then comes semantic analysis. This checks whether the meaning is correct. Okay, just like you can think this way also, whether variable types are well defined or defined correctly. Okay, so this is semantic analysis. Then optimization is done. Here unnecessary steps are actually removed. This way efficiency is maximized. So this is optimization step, that is the fourth step. Last step is the code generation. Everything is okay, now code is generated. That means in terms of machine instructions, the code is generated. And then that machine instructions are converted into binaries. And then those things are followed by the CPU. So for example, you can see on the screen your C++ code, a part of the program I am displaying on the screen. Say integer a is equal to 5, integer b is equal to, say for example, 10, integer c is equal to a plus b. So you know the program output. It will give you 5 plus 10 is equal to 15. Here int integer, this means you are assigning the variable type. You are defining the variable actually, what type of variable this is. So these are integer types. Now this is what this is written in C++. Okay, now this will change to assembly instructions. So in case of assembly instructions, that thing will be that will look actually completely different, like move r1, 5, move r2, 10, then move r3, r1, r2, like this. Okay, or better to say, this is assembly instruction. Assembly. First C++ code, then assembly, then machine instruction. So these are the steps actually. So in assembly code form, this is the result. Here, last one. First move R1 5, then move R2 10, then add R3, R1, R2. Add. So you can see there are two opcodes, MOV move and ADD add. Two opcodes are there. Means task to perform. That is the meaning of opcodes. And then one more thing is there, R1, R2, R3 is there, 5 and 10 is there. These things are there, R1, R2, R3, 5, 10. So 5 and 10, these are data, and R1, R2, R3, these are registers. And as a whole, these are called operands. Okay, operands. So operands is the summation of this data as well as registers. So up to this is done. Now, after doing all these things, now your code is available in assembly instruction form. This is now converted into binary form. Then your CPU starts actually working. These binary forms is stored in the memory. Okay, then the CPU fetches one instruction at a time. One instruction at a time. Then it decodes the instruction. What task has been assigned? That means it tries to know the opcode. Okay, and accordingly, step by step, the entire program runs, and you can see the output on your screen. Okay, so this is the function of a compiler. So many tasks are there, followed by a computer or followed by a CPU. Then only you can see the result on your screen. But these things happen so fast that in case of small programs, it may seem to you instantaneous. Just for this example, integer a is equal to 5, integer b is equal to 10, then that summation a plus b less than 1 second. Okay, means instantaneous. You can see, you can say the result is, or the output generation on the screen is instantaneous, but actually not instantaneous. Actually, so you can see, though so many processes are there, but all these things happen so fast that it almost seems to be instantaneous. But in case of huge programs, like say for example, you have written your C++ code to solve a problem on CFD, that is a computational fluid dynamics. In that case, several days may be required to solve the given problem. Anyway, those things will be discussed in separate videos. In this video, up to this, okay? How the actually CPU performs the your CPU actually, how actually compilers work. That was the main topic of discussion in today's video. Anyway, so this was all about today's video, and this is the end of this video. If you found this video interesting, so please like, share and subscribe to our channel. This is the end. Thanks for watching.